just kind of give you an idea of the best way to go about approaching them and taking a look at them is understanding that working off the same acceleration equations we've used in the first semester, right? We're talking about A equals VF minus VI over T. We're talking about D equals VIT plus AT squared over 2. We're talking about D equals VF squared minus VI squared over 2A. All three equations we use in the first semester, we're just going to use them in conjunction with the fact that we now know that acceleration is equal to the force divided by the mass. And just kind of using this A to fill in that missing variable that might be here, or using the A from the force and mass to figure out fill in that missing variable, or to maybe use one of these other equations to fill in the A value for F equals ma. So let's take a look at number 4. In this one, we have a truck exerts a force of 24,000 newtons, so it's pushing this way, 24,000 newtons, and it's going to do that for 36 seconds. The truck itself has a mass of 35,000 kilograms. Okay, our end goal is to find, if it's starting from rest, that again tells me VI is 0, what is its final velocity? So we're looking for VF. Okay, so we have T, we have VI, we have VF. That's going to take us to this equation right here, okay, where we need to find VF based on VI and T. We have a force and mass, which is let me get A, which is going to fill in that missing value there. So how do we find VF? Well, VF, if we rearrange everything, is just equal to VI plus A times T. Okay, and that's just rearranging everything to solve for VF, just doing the simple algebra there. And we know VI is 0, so that term's not really going to matter. We just need A. We need to know what that acceleration is. And we know we can get that now because we have the force on the system and we have the mass in the system. So we're going to take F over m to get the force, and that's 24,000 over the 35,000. And that's what's giving us an acceleration of, I think it's like 0.6 something. 0.69 meters per second squared. Okay. And then we would take that, plug that back into our equation up here that we know is going to give us our final value, 0.69 meters per second squared, multiply that by the 36 seconds, and that's what's going to tell us our final velocity is 25 meters per second. So again, it comes down to what information do we have based on the initial thing, VF, VI, and T. That's going to let me get A. Or VF and VI and T are the three things that we're working with. And we can get A now from F over M. And the second problem, we have that 3.4 kilogram axe head swung at a tree at 23 meters per second. So we know our mass is 3.4 kilograms. We know that axe head, as it was moving into the tree, okay, is traveling at 23 meters per second. So that's going to be our VI. It stops a distance of 4.3 centimeters into the tree. And again, because it stops, that means our final velocity is going to be 0. We want to know how much force it exerted on the tree. Well, we know F equals ma. There's our force. We've got m. That was given to us by the mass of the axe head. We need A. And A, in this case, is going to be based off VF, VI, and D. The only equation we have there that has those variables in it is going to be this one here. D equals VF squared minus VI squared over 2A. And we just solve for A, and it's VF squared minus VI squared over 2D. And then we would just plug our values in. We know VF, we know it's stopping at 0. We know it's starting at 23 meters per second. We'd square that. The key here though is, again, one of the keys here again, make sure our units match up. This needs to be meters, not centimeters. So this would be 2 times 0.43 meters. You make sure we get that in meters out, not in centimeters. And that would give us our acceleration value, which for this problem, I can't remember off the top of my head, but you put that in the calculator really quick, 23 times 23, 2 divided by 0.043, gives us an acceleration of 6,150 meters per second squared. And then we just go multiply that by the mass of the object, so 3.4 kilograms times the 6,150, and that's going to give us the 21,000 newtons. So again, it's look at what you have to